Okay. Okay, one of the most important rules of log is that rewriting it as an exponent rule. And I'm going to just write it on the board. Log base A of x equals y really means a to the y equals x. And I think we talked about this already. And remember, you always start with the base to the other side and come back. Same thing happens here. You start with the base is the exponent, the base of the log, the other side, and then come back. Now, the reason that this is really one of the most important ones is because this is how you're going to solve. This is how you rewrite. Find the inverse. Anything you have to do with any of that, you're probably going to have to use this rule. Okay, another important rule is with, you have multiplication. You have multiplication inside the log, it becomes addition outside the log. And the way that kind of makes sense is with exponents. If you notice, the answer to the log is really the exponent, and when you multiply bases, you add the exponent. So this is that would be how to prove this, is if you multiply the bases, you add the exponent. So far, is that okay? Great. Okay. Another rule is for division, log base A of x over y is log base A of x minus log base A of y. And the same idea applies if you divide, you're going to divide the exponent. Okay, sorry. Okay, so are these two rules okay? There's one more expanding rule, and that is if you take a log and the inside has a power, that power can come down. N log base A of x. And again, that should make sense because if you take a power to a power, you're going to multiply the exponent. So that kind of reinforces why this is true. So just the basic log rules. You're good. We can use these rules to solve, and I'm going to try to incorporate all of these rules into a solving somehow. I'm going to try. Okay, let's pretend we have okay, I'm just going to make it up. Log base 2 of x plus 2 log base minus 1 equals 1. Okay, because I just made this up, this might not work out very easily. I'm sorry, somebody is fronting me at the same time. Okay, so we cannot do this rule right here until the log is all by itself. So we have to use these rules to combine logs into one single log before we can rewrite it. So, which rule do you think that we'll use first? 1, 2, or 3? Just 1, 2, 3. Yes, that's perfect. 3 is perfect. With the chat where you're typing in, because we're the only two in here, saying something to the main room is the same thing as just saying it to me. But if there was other people in this classroom, you could, and somebody says like something, and you wanted to just comment to them, that's why you would change that. Just a sidebar. Okay, rule 3. Rule 3 is the one with the exponent, and it has a number in front. And we have a number right here in front. What can we do with that number? I think you also have permission to write on the board if you want to try to rewrite it yourself. Or at least, oh, perfect. You did, never mind. Great, that is perfect. So we have log base 2 of x plus log base 2 of x plus 1 squared equals, that's supposed to be the number 1, and that's equals 1. So far, so good? Now, which rule are we going to use? Great, perfect. Do you want to try it? That is great. No, no, parentheses is fine. And actually, it might be a good idea to put all of this in a parenthesis just so that all of it is inside the log. But this is perfect. So far you've done great. Now we have a single log on this side. We can use that first rule. We're going to get the base is 2. We're going to get 2 to the other side, which is 1, equals x times, and I'm going to go ahead and multiply this out, x squared plus 2x plus 1. So far, so good? And now this is just like an algebra 2 problem. We would multiply this out again. 2 equals x cubed plus 2x squared plus 2x minus 2. And unfortunately, I don't think this factors. So, this is 0. Not minus 2. After you subtract this over, you get minus 2. But I don't think this factors or solves. So, unfortunately, I think this would be the end of this problem. But the point is, you can use the rules to get it to a place where you can figure out if it does solve or not. It's okay. Clear slide clears the whole thing. Did I make a mistake on the slide? Did I distribute wrong? It should have been just an x. It should have been x cubed plus 2x squared plus x. And then when you subtract the 2 over, you would have gotten minus 2 equals 0. There is a arrow that points back. It's to undo. Okay, so another kind of log problem. Let's see. I'm thinking. Okay, let's do an expand problem. Log base 3 of x, or 9x squared, over the 4th root of y. This is just practice using our rules. We're going to try to use the rules 1, 2, and 3 to expand this out. No, it's a 4th root. It's log base. The log has a base of, I'll do this. The log has a base of 3. So which one of the rules would I use first? The separating multiplication, separating division, or pulling down powers? Perfect. Separating the division. And what does division separate into? Sure. Yes. That's perfect. And now, there's a couple steps you can do at the same time. With this second one, what rule are we going to use? That's perfect. Because a root is actually a power, and a cube root is really a power of what? Close. It's actually 1/3. Little sidebar. If you have whatever root, it means x to the 1/a power. So for that one, you'll get negative 1/3 log base 3 of y. And for the first part, we can actually do two steps in one. We can say log base 3 of 9, and then plus 2 log base 3 of x. So the 2 comes down. In this one, it was expanding. This was, we will use this later in calculus when we do derivatives. It is a lot easier to take the derivative of something that looks like this than something that looks like this. So we're going to use this breaking down in that manner. But we're actually not done. There is something we could do right here. Because 9 and 3 have a relationship. What is 9? Yes, perfect. It's 3 squared. So what would be the log base 3 of 3 squared? Not exactly. Remember, the power comes down, and this is a rule. Log base 3 of 3 just becomes 1. So this is 2. Yep, perfect, it's 2. And then you would keep on going with the answer. So this expanding, we've done one expanding, and we have done one writing as a single log. Do those two concepts make sense? Perfect. Do you know what kind of other problem you want to deal with? Not deal with, but go over? Okay. I'm actually teaching someone that in a whiteboard. So let me get Can I clear this whiteboard? Can I clear this whiteboard? Okay. Okay, this is a chart that I don't memorize the unit circle because of reference angles. If you know 0, pi over 6, which is 30, pi over 4, which is 45, pi over 3, which is 60, and pi over 2, which is 90, then you can get pretty much any one as long as you know. I think that somebody taught you sometimes all students take calculus, all positive here, sine and cosecant positive here, tangent, cotangent, cosine and secant. So far, is that okay? Okay, so sine, cosine. And if you need tangent, just remember that tangent is sine over cosine. So with this chart, you can get all 6 identities on any reference angle. It's a very easy chart. That's the only reason I have it memorized. 0, 1, 2, 3, 4. And then with cosine, you go 4, 3, 2, 1, 0. Take the square root of everything. Yes, some stuff does simplify, but you can deal with that later. Like the square root of 4 is, really 2. You take the square root of everything, and then divide by 2. I think this is easier to deal with and to write down than the unit circle. So, and then really, when you do tangent, you're going to do the top of the sine over the bottom of the top of the sine over the top of the cosine, because, when you flip it, square root of 0 is 0 over 2 times, when you're dividing, you multiply by the reciprocal, 2 over the square root of 4. Your denominators are always going to cancel, and you're just going to get top of sine over top of cosine. So, like if I wanted the tangent, just to find out where the tangent is, the square root of 3 over 1, or just the square root of 3. I need to look where the sine is the square root of 3, and the cosine would be 1 on top. Do you think you could find out where the arctan of square root of 3 is? Yeah. Basically, to find arctangent, we're going to have to look at arcsine over cosine. And so really we want the question arcsine over, let me say something. Okay, so what this means is that the tan of some angle is the square root of 3. And if you want it to be a fraction, it's the square root of 3 over 1. And sometimes going to sine and cosine helps, because this bit says the sine over the cosine is the square root of 3 over 1. So go to your chart and find where the sine has a square root of 3 in it, and the cosine has a square root of 1 in it. And so what angle would that be? Pi over 3, yeah. Pi over 3 is perfect. So your answer is pi over 3. And if they needed 2 answers, like give me all the, all the angles between 0 and 2 pi, well then you use this chart and you say, well, I could be pi over 3 in this quadrant, but I could also be pi over 3 in this quadrant, tan is positive there. So I say, this gives me the angle in quadrant 1. In quadrant 4, I would say I have to go pi, and then another pi over 3, so 4 pi over 3 also works. Does that make sense? And so I like using these. I think these are easier to use than the unit circle. But, this is easy to write down and then just simplify it out. Square root of 4 is 2 over 2. This comes out to be 1. This one is really 0. Simplify it out, and then very easy to, just write down, like on the AP exam, as soon as you get it, write this down real quick. So anytime you need to refer to it, you can. Yeah, I don't remember the whole unit circle. I don't remember people's phone numbers. I'm sorry. So is this kind of part of trig okay? I think this is more of the evaluating trig. You do need to know your trig rules. Your double angle, your Pythagorean identities, things like that. You're going to need to know those rules. Yeah, I'm pretty sure that I have a sheet that has like all the log rules, all the trig rules, everything on one sheet. I'll have to look it up and post it. If I post it, I'll post it in the review for Unit 0. There's also online flashcards that you can take advantage of. And you can cut and paste and so you don't have to go out and buy flashcards and everything like that, but you can make online flashcards. So do you have any other questions before I close out the archive? Take your time. Ooh. Yes, I can. That kind of problem I can't make up on my head. Do you, there's no homework on that. What to do. Yeah, I know what you're talking about. Just give me a minute to look one up. Can I clear this board? Okay, clearing slide. Cleared. That's a tan X. Okay, this I think is kind of what you're talking about, where you have two sides and you want to just verify. We're not going to be using this verification thing in calculus, but we are going to be using the rules. So these are great practice for the rules. So, some of the rules you should know is that tan is 1 over what? Yeah, you need the rules. Yeah, these should be second nature. Tan is 1 over cotan. Cotan is 1 over tan. Secant is 1 over what? Great. And then cosine is also 1 over secant. Sine is 1 over Cosecant, perfect. And then cosecant is also 1 over sine. These are huge. Knowing that tan is sine over cosine is also huge. That's going to be very important. Sorry about the horrible handwriting. And then cotangent will just be the flip of that, cosine over sine. So far, so good. Great. 3 more identities. They're called the Pythagorean identities, and they come up a lot. One of them is easy. You probably have heard of it. Sine squared x. You know, all of these had an x in it. I just didn't write the little x, okay? That's a C. Sine squared plus cosine squared x. Cosine squared x equals what? Perfect. It equals 1. This is probably the one that most people have memorized, and they don't have the other 2 memorized. Do you have the other 2 memorized? Okay, I don't. You do? That's awesome. I personally don't. I always derive them by knowing this, and then if I divide by sine squared sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent squared. And 1 over sine squared is cosecant squared. So that gives you the second one. And now if you want the third one, you divide by cosine squared. Sine squared over cosine squared is tangent squared. Cosine over cosine is 1, and 1 over cosine squared is 1 over secant, secant squared, not 1 over. So that's an easy way to get the other 2 if you know just this one. All you have to do is divide through by either sine squared or cosine squared, and you get each of these. So when you want to verify an identity like it says here, it's easier to work with the more complicated side. Okay, bye. Have a great time. Archive